Chapter 7, Section 7.8, Addition Polymerization. Now this is a continuation of the previous video that's revised from Section 7.1 to 7.7, which is revision of the Sec 4 NA syllabus. Now we're covering 7.8, 7.9, which is addition, so that you can take the O-level science chemistry. So you need to describe the addition polymerization of ethene to form polyethene, as well as to deduce the structure of a polymer from its monomer and vice versa. And of course take some uses of polyethene. Now, what is a polymer? Remember the definition? A polymer is a type of long chain macromolecule. Macro means giant. Okay, giant molecule that is covalently linked together, joined together. If you can't spell the word link, just say join, by many small repeat units called monomers. So when you have many small repeating same kind of unit joined together, the small unit is called monomer, and the one that's joined together to form big one is called polymer. So you have many monomer, and when it's linked together by covalent bonds, it forms a polymer. So polymer is a large molecule. Now the process, addition polymerization, occurs when monomer units, mono means one mer, okay, small units, join together without losing any molecules to form a large polymer. Alright, to form a large polymer. So alkenes can undergo addition polymerization. Now do you realize that this is addition reaction? Just now previously we learned about addition of hydrogen, addition of bromine. Now we learn addition of itself. It adds to itself. So when all the alkenes, the ethenes join together, it form polyethene. Alright. So condition: high pressure, high temperature, and catalyst. The detail no need to know. Alright, no need to remember what's the exact temperature, because different kind of addition polymerization has slightly different conditions. So high pressure, high temperature, catalyst are the three conditions you must remember. That's all. Now, for example, you have ethene. Ethene is C2H4, right? So if you draw a structural formula, you have 1 ethene, 2 ethene, 3 ethene, 4 ethene down there. So you align ethene together and you break the center, the single double bond to form single bond. So you break double bond to form single bond, break double bond form single bond. Okay, that's exactly the addition reaction. Addition reaction breaks the double bond between the carbon and to form two extra single bonds. So when you form all a single bond, they join together, and that's how it becomes the polyethene. Alright, so when all join together form polyethene. So all the carbon-carbon double bond breaks, they form single bond. So each monomer forms single bond with two other monomer, and they join to form a polymer. The polymer is a large molecule. So if you ethene, you form polyethene. Propene, you form polypropene. So there are some ways to write the equation. Is that, for example, ethene, you form poly bracket ethene. If you give propene, you say poly bracket propene. And this is the partial structural formula. N bracket C2H4, that you become this. Of course, you remember this one. This is ethene. N number of ethene. The number in front means the independent discrete unit, separate unit. So n number of ethene. But this structure here shows this structure repeat n number of time. Okay, you realize it actually repeat n number of time. So what happened is, if I have 100 unit of ethene, then you join together and this unit repeat 100 times, a long chain. Alright, so n actually is a large number. And again, temperature, pressure, catalyst, just say high temperature, high pressure, and catalyst, no need to know the detail. Ethene become poly bracket ethene. Right, next one. The repeat unit is the C2H4. Do you realize there's two bonds at the side? Alright, this is a Lego piece where you can join. Alright, and the formula of polymer can be written using its repeat unit. For example, you put the repeat unit, put bracket, and put n outside. So by writing the repeat unit with n, that represents the polyethene already, and n represents a large number. So it can be between 10,000 to 30,000. Now, for example, polyvinyl acetate, don't need to memorize, they will give it to you. If this is given as a polymer, in other words, it repeats itself until n very long. So how do you identify the monomer? So you know monomer is always identified by the two carbon in the center. So what you need to do is just cut it like this. This piece is repeat unit. This piece in the center is the repeat unit already. Alright. So identify the repeat unit. So repeat unit is actually based on two carbon. It's always two carbon, no matter what. It's always a two carbon. Alright. So repeat unit. Then after that, you remove out the repeat unit. You remove out the repeat unit from the polymer. And the repeat unit, you simply remove the single bond on both sides and you convert the center to a double bond. Okay, so convert the single bond into a double bond in center. That's all. So basically the steps are very simple. First, given a polymer, you identify 2 carbon. Okay, just select any 2 carbon. It can even be here. It can even be this carbon. Then this becomes repeat unit. Alright, just look for 2 carbon and this repeat unit. So once you know repeat unit, you remove the single bond on both sides, and then the center bond change to double bond, and you get the monomer. So some uses of addition polymers, for polyethylene, can be molded. They are plastics. They can melt easily and mold different shape. So you can mold different shape, and you can make plastic toys, cling film, okay, those microwave films, plastic bags, buckets, and so on. And of course, other addition polymers are polystyrene, okay, something that is hard, light, and brittle, can use for disposable container. PVC is what you see, all those pipes, water pipes, okay, or even rain clothes or thin gloves is PVC. Teflon, you may not realize it, but I think this name you probably heard before. Teflon is the non-stick frying pan. Okay, one of the kind of material that can be put on the frying pan, coated on frying pan, so the food doesn't stick to it easily. So basically, addition polymers in general, think of it as plastics. So they are good insulators of heat and electricity, and of course resistant to chemical attack. So plastics can contain acid, and acid cannot melt the plastic. Now, plastics has its own issue. The last section we talked about the pollution problem. So we have a lot of advantage of plastic using plastics. Okay, they are very, very often used. Okay, in place of other natural things like wood, metal, which of course much heavier, even cotton. Okay, it is not very durable. So the reason for using plastic is because it's relatively cheap, easily molded into different shapes. It's light, tough, and waterproof. And you love having a lot of plastics, right? So, and of course, it's also durable. Durable means it does not break down easily. It does not rust or whatever. So one thing you must know is that plastics are non-biodegradable. This is a very important term you must memorize. What is the meaning of non-biodegradable? Here, non-biodegradable is here. It means it cannot be broken down naturally by bacteria. So you leave it in the soil, you'll be there after 1,000 years, it's still there. Alright? But of course, some plastics, when exposed to sunlight, actually they can actually become hardened and then they can actually break down. But they take a long time. And because plastics are non-biodegradable, bacteria cannot add on plastic. The bacteria cannot decompose the plastic. So there's a build-up of waste. Plastic waste become very abundant. Alright? So non-biodegradable simply means cannot be broken down naturally by bacteria. Remember the keywords. Now, plastic is also flammable. That's another problem. Of course, you can burn plastics. If you don't want the plastic to be lying around on the ground and you already dispose them, of course you burn it away, right? But burning, it can actually produce poisonous gas. Alright, for example, PVC, it can produce hydrogen chloride gas, which is poisonous. So by burning, it actually, there's a danger also, of course. When there's a lot of plastic, when it catch fire, it can burn very easily and it can produce poisonous gas. Now, when plastic is thrown into sea, it can endanger marine life. So some animals in the sea, animals thought that it's food. They thought it's food and they choke them. Alright, if they swallow the plastic, it cannot digest, it can choke up. And of course, plastic can clog up rivers and drains. Okay, you know, it takes a very long time to decompose. In fact, it won't decompose naturally. So under strong sunlight, maybe it'll break down slowly. Of course, in this case, it becomes a breeding ground for mosquito because it can actually clog up the drains and rivers. Now, many plastics produce poisonous gas. Okay, when incinerated means burn. Incineration plant is for burning of waste. Alright, so by burning, it can produce poisonous gas. For example, PVC produces hydrogen chloride, and this is the acid. If it dissolves in rainwater, it forms hydrochloric acid. So it's very dangerous. If you breathe this gas in, you get choked, and it's very acidic, and you can cough out blood. Alright, so of course, it produces air pollution when burned. So the best way to deal with plastic is to reuse or recycle them. Okay, the word reuse simply just take it and use for different purposes. For example, after you finish drinking the soft drink from a plastic bottle, you can use it to contain water, or maybe use it to plant plants or whatever kind of thing. Recycle, it could mean that the plastic bottles are broken down, okay, straight into pieces, and then mold into different new plastic objects. Okay, recycle. Alright, that's all for this chapter.